Hello everyone, this is Anil. Welcome to the first class of calculus. The topic chosen for this class is continuity. In this class you will learn L'Hopital's rule, which reduces the tedious steps involved in solving certain types of limits. At the end of this class you will know how to solve the problems on continuity effortlessly. In this class, we shall take the problems from the NCERT Book of Exemplar Problems. If you are ready, we shall begin. Before we take up problems on continuity, we shall recall the definition and meaning of limit of a function continuous at a point, and a continuous function. Let y equal to f of x be a real function. When we say a function is real function, it means that both domain and range of the functions are subsets of real numbers. Let a be any real number. We know that when we write x tends to a, it means that x takes the values closer and closer to the value a, but not equal to a. Suppose the function f of x, the value of the function f of x approaches the value L whenever x approaches the value a. Then we say that L is the limit of f of x as x tends to a, and we write this as limit of f of x as x tends to a equal to L. When we say x tends to a, we can approach the value a through the values which are lesser than a, that is approaching the value a from the left, or we can approach the value a through the values which are greater than a, means that approaching the value a from the right. In order to make this concept clear, we shall consider an example. Consider a function f of x defined as x squared when x not equal to 3 and 2 when x equal to 3. Y equal to f of x equal to x squared clearly is an upward parabola, but the point 3, 9 is not included in the graph. The reason is at x equal to 3, the function is defined as 2. So that is this point. So here we don't have 3, 9 on the curve. So there is a break at this point. Now to find limit of f of x as x tends to 3. We can approach the value 3 through the values which are lesser than 3. As x takes the values closer and closer to the value 3, approaches the value 3 from the left, that is through the values which are lesser than 3. Say 2.9 close to 3, 2.99, 2.999, 2.9999, which is much closer to 3. The corresponding values of f of x, that is x squared, are given here. Just look at this value, 8.9994001 is very close to 9. Here we say that as x approaches the value 3 from the left, f of x approaches the value 9. So this value is called left-hand limit of the function, and we write this as limit of f of x as x tends to 3 minus on the top indicates you are approaching the value through the values which are lesser than 3 is 9. That is the left-hand limit, because we approach the value 3 from the left of 3 on the number line. Now suppose you take the values of x 3.01, 3.001, 3.0001, 3.00001. That is approaching the value 3 from the right. That is through the values which are greater than 3. The corresponding values of f of x equal to x square are given here. Just look at this. When the value of x is very, very close to 3, the value of f of x will be very, very close to 9. So here we say that 9 is the right-hand limit of the function. And we write this as limit x tends to 3 plus, which means that you are approaching the value 3 from the right. F of x, that is given to be 3. Whether you approach the value 3 from the left or from the right, the value of f of x approaches to 9. Thus, as x tends to 3, the value of f of x approaches the value 9. Here 9 is called the limit of f of x as x tends to 3. We write this as limit of f of x as x tends to 3 is 9. Now we shall define the limit of a function f of x as x tends to a. So first we shall define left-hand limit. Limit f of x as x tends to a minus equal to L1 means that as x approaches the value a from the left, that is through the values which are lesser than a, the value of f of x approaches the value L1. L1 is the left-hand limit of f of x as x approaches to a. The same way, we define right-hand limit of the function. Means that as x approaches the value a from the right, that is through the values which are greater than a, the value of f of x approaches the value L2. So L2 is the right-hand limit of the function. If both L1 and L2 exist, that is, if both left-hand limit and right-hand limit exist and are equal, only then the common value L is called the limit of the function f of x as x tends to a. And we write this as limit of f of x as x tends to a is L. In certain problems, f of x will not be defined separately for x less than a and x greater than a. In such problems, to find the left-hand limit, replace x by a minus h and take limit as h tends to 0. So that is because you are moving to the left of a, that is a minus h. H is a very small number, a minus h. Now you are to the left of a. Now as h tends to 0, this a minus h becomes a. Rather, you are moving towards a from the left. So that gives the left-hand limit. In order to take the right-hand limit, replace x by a plus h. That is, you come to the little right of a, say a plus h, and take limit as h tends to 0, which is same as moving towards a from the right. As h becomes 0, a plus h moves towards a, that is from the right. So we shall replace x by a plus h and take limit as h tends to 0. So that gives us the right-hand limit of the function. Now we have a key point. Left-hand limit of f of x as x tends to a minus is limit of f of a minus h as h tends to 0. In the same way, to find the RHL, replace x by a plus h and take limit as h tends to 0. Remember, we need to make use of this method only when f of x is not defined separately for x less than a and x greater than a. Now consider this definition. A real function f of x is said to be continuous at a point a in its domain if limit of f of x as x tends to a equal to f of a. That means limiting value must be equal to functional value at x equal to a. Then we say that the function is continuous at x equal to a. So since you have a limit expression here, left hand and right hand limit both must be equal for limit to be defined, and that must be equal to f of a. Now we shall consider the earlier example. In this one, we found the limit of f of x, as x tends to 3 is 9. But here in the given problem, if you find f of 3, that is the functional value, direct substitution, when x equal to 3, f of x is defined as 2. So clearly, this value is not equal to limit of f of x as x tends to 3. So therefore, f is not continuous. Not continuous or simply discontinuous at x equal to 3. Corresponding to x equal to 3, you don't have a point on the curve. 3, 9 is missing. So here the curve has a break at the point 3, 9, or simply we can say at x equal to 3. So discontinuous means the curve has a break at that point. Now, in order to make this function continuous, let us redefine this function. Say f of x equal to 9 if x equal to 3. So then this point will not be here. Then you get the point on the curve only corresponding to that. So there won't be any break on the curve. So now limit of f of x as x tends to 3 already found, that is 9, which is same as f of 3. So at x equal to 3, f is continuous. So in other words, the curve has no break at x equal to 3. Geometrical meaning, if f of x is continuous at x equal to a, then there is no break in the graph of f of x at x equal to a. That is at the point a, f of a. Conversely, when the curve has no break at the point a, f of a, the function will be continuous at x equal to a. So this is defining continuity at a particular point. Now we shall generalize this definition of continuous function. A real function f of x defined in an open interval or in a closed interval is said to be continuous if it is continuous at every point of its domain. So here you should remember, when you need to find the continuity of the function at x equal to a in the closed interval, you need to verify only limit of f of x as x tends to a plus. So here you can approach a only from the right, not from the left, because a is the end point. There is no point to the left of a. This should be equal to f of a. Then we say that it is continuous at x equal to a. Now to verify the continuity of the function at x equal to b, we need to find the left-hand limit of f of x as x tends to b, that is b minus, because there is no point to the right of b. You can approach b only from the left. That must be equal to f of b. If so, f is said to be continuous at x equal to b. Find k so that the function is continuous at x equal to pi by 2. So since the function is continuous at x equal to pi by 2, limit of f of x as x tends to pi by 2 will be equal to f of pi by 2. Here it is given that when x is pi by 2, f of x is 3. And when x is not equal to pi by 2, the function is defined as k times cos x upon pi minus 2x. So here limit x tends to pi by 2, take k times cos x upon pi minus 2x, f of pi by 2 is 3. So here in this function, if you take x equal to pi by 2, let us see what value we get. K times cos of pi by 2 upon pi minus 2 times pi by 2. 2 get cancelled. Pi minus pi, 0. Since cos pi by 2 is 0, you get 0 upon 0 form. So therefore, we shall use L'Hopital's rule. In order to apply L'Hopital's rule, all you need to do is just differentiate the numerator, denominator separately. Please don't apply quotient rule. So limit x tends to pi by 2. So that is k times minus sin x upon 0 minus 2 equal to 3. Now substitute for x, that is minus k sin of pi by 2 upon minus 2 equal to 3. So that gives us k upon 2 into 1, sin pi by 2 is 1, equal to this. So k equal to 6. You are not supposed to use this method in the theory exams. This is only for MCQ or any entrance test. Second question is, if f of x is defined as mod x upon x, if x is a non-zero real number, and f of x is 0 if x is 0. Now we need to discuss the continuity of the function at x equal to 0. So since you have mod x here and f of x is mod x by x, when x not equal to 0, it is convenient for us to define f of x separately when x is less than 0 and x is greater than 0. If x is greater than 0, you get mod of x is x itself upon x, that becomes 1. So f of x will be 1 when x is greater than 0. When x is negative, mod x is minus x. So we get mod of x will be minus x upon x equal to minus 1. So when x is 0, that is 0 itself. Since f is defined separately for greater than 0, less than 0, we need to find left hand limit and right hand limit separately. LHL is limit f of x as x tends to 0 minus. You are approaching 0 from the left of 0. That is x tends to 0. So here when x is less than 0, f of x is minus 1. So here write minus 1. There is nothing to substitute for x because there is no x here. So minus 1. The right hand limit is limit of f of x as x tends to 0 plus. You are approaching 0 from the right of 0. So once you take the appropriate function, you don't have to write any sign over here. That is, when x is greater than 0, the function is defined as 1. So that becomes 1. So here LHL not equal to RHL. Limit doesn't exist. Limit of the function f of x as x tends to 0 does not exist. So therefore, it cannot be continuous, though f of 0 is defined. F of 0 is 0. F is not continuous at x equal to 0. Third question, find the values of a and b such that the given function is continuous at x equal to 4. F of x is defined as x minus 4 upon mod of x minus 4 plus a when x is less than 4. When x is less than 4, x minus 4 will be negative and therefore mod of x minus 4 is negative of that to make it positive. Remember, mod x is minus x whenever x is less than 0. But minus x will be positive. Even this will be positive. You can write this as x minus 4 upon minus x minus 4 plus a. That becomes minus 1 plus a. Now, when x is greater than 4, x minus 4 will be greater than 0. And therefore, mod of x minus 4 is x minus 4 itself. So this takes the form x minus 4 upon x minus 4 plus b. That is 1 plus b. So when x is less than 4, the function is minus 1 plus a. When x is greater than 4, the function is 1 plus b. Since the function is defined separately for the values which are less than 4 and greater than 4, we need to find the left hand and right hand limit. Since the function is continuous, both left hand and right hand limit will exist and are equal. So we shall write left hand limit, limit x tends to 4 minus f of x is same as limit of the function as x tends to 4 plus approaching 4 from the right hand limit is same as the functional value. Now, when x is less than 4, f of x is defined as minus 1 plus a. When x is greater than 4, f of x is defined as 1 plus b. And f of 4 is a plus b. So the expression is free from x. So you get minus 1 plus a equal to 1 plus b equal to a plus b. Equate these two and these two separately to get the values of A and B. So minus 1 plus A is A plus B. A get cancelled, you get B equal to minus 1. Now equating the last two terms, 1 plus B is same as A plus B. B terms get cancelled, A equal to 1 is the required value. Here these two get cancelled, here these two get cancelled. Next, fourth problem. So we need to discuss the continuity of this function at x equal to 0. So first we shall find the limit of the function as x tends to 0. If that is same as f of 0, that is 0 in this case, then the function is continuous at x equal to 0. Consider limit x tends to 0, f of x. That is limit x tends to 0 mod x into cos of 1 by x. The limit of the product is product of the limits. You can write it as limit of mod x into limit of cos of 1 by x as x tends to 0. So here, remember, mod x is a continuous function. Rather replace x by 0, you get 0 here. This is 0 into. Now as x tends to 0, 1 by x tends to infinity, plus or minus infinity. That depends on x approaches to 0 from the right or from the left of 0. Whatever the value of 1 by x, however large or however small, the value of cos of an angle always lie between minus 1 and plus 1. But this doesn't approach us to any finite value. But this will be a finite value which oscillates between minus 1 and plus 1. If you take this limit independently, we must say limit doesn't exist because the values are oscillating between minus 1 and plus 1. But here in this particular problem, so whatever the quantity you get here, value, that is multiplied by 0. So final expression will be 0. So here, write a finite value oscillates between minus 1 and plus 1. So you get this as 0, which is same as f of 0. So the limiting value is same as functional value. Therefore, f is continuous at x equal to 0. Now the next problem is fifth one. Given the function f of x is 1 upon x plus 2, find the points of discontinuity of the composite function f of x. So remember, f of x must be defined. So here f of x is x plus 2 is not defined when denominator x plus 2 is 0. That is when x equal to minus 2. So we got 1 point of discontinuity. So now we shall find f of x. So y equal to f of x. That is f of x is 1 over x plus 2. For convenience, I'll write it as f of t, where t is 1 over x plus 2. What is f of t? Again, use the same definition. F of x is 1 upon x plus 2. So that becomes 1 upon t plus 2. But what is t? Substitute back. 1 upon x plus 2 plus 2. On simplifying, you get this as 1 over 1 plus 2 times x plus 2 upon x plus 2. That goes to the numerator. So y becomes x plus 2 upon 2x plus 2 plus 1. That becomes 5. Is defined if 2x plus 5 not equal to 0. So x should not be equal to minus 5 by 2. That means at x equal to minus 5 upon 2, the function is not defined, means not continuous, rather discontinuous. So therefore, the points of discontinuity are x equal to minus 2 and x equal to minus 5 by 2. Sixth question. Find all the points of discontinuity of the function f of t, where t is 1 upon x minus 1. T is not defined when x equal to 1. So one point of discontinuity we got, that is x equal to 1, not possible. Now we shall find f of t. So f of t, you can write it as 1 over factors of t square plus t minus 2, t plus 2 times t minus 1. Now you substitute for t, 1 over 1 upon x minus 1 plus 2, 1 upon x minus 1 minus 1, that is f of t, 1 upon, this will be 1 plus 2x minus 2 upon x minus 1, that goes to the numerator. Here 1 minus of x plus 1, denominator x minus 1 goes to the numerator, x minus 1. So that becomes x minus 1 the whole square upon 2x minus 1 into 2 minus x. So which is not defined when 2x minus 1 equal to 0 and 2 minus x is 0. So f of t is not defined when 2x minus 1 equal to 0 or 2 minus x equal to 0. That is when x equal to 1 by 2 and x equal to 2. So once the function is not defined, it cannot be continuous at that particular point. So we have 3 points of discontinuity for the given function. The points of discontinuity are 1, 1 by 2, and 2. These are the 3 points of discontinuity. Next one is prove that the function f defined by f of x equal to x upon mod x plus 2x square when x is a non-zero number and k when x is 0. So we need to prove this remains discontinuous at x equal to 0 regardless of the value of k. Here, first we shall find the limit of the function at x equal to 0. Here, mod x is not a factor of the function. It is in the denominator. So we need to find left-hand limit and right-hand limit separately. Left-hand limit, limit f of x as x tends to 0 minus f of x is x upon mod x plus 2x square. Now when you approach x, when you approach 0 from the left, when you approach 0 from the left of 0, x is negative. When x is negative, mod x is minus x. That should be taken here. Limit x tends to 0, x upon minus x plus 2x square. Now we shall simplify this. Limit x tends to 0, x upon x times, taking x common factor, plus 2x. These two get cancelled. In the next step, when you substitute the values, you get minus 1 plus 2 times 0. That is minus 1. So the left-hand limit is minus 1. So we got left-hand limit equal to minus 1. Now finding the right-hand limit, RHL 0 plus. So as x approaches to 0 from the right, x is greater than 0. So mod x is plus x. Now again taking x common factor, you will get plus 1 plus 2x. So here plus 1 plus 0. That becomes plus 1. So the right-hand limit is plus 1. When these two are not equal, limit doesn't exist. LHL not equal to RHL. Therefore, limit f of x as x tends to 0 doesn't exist. So therefore, it cannot be continuous for any value of k. F is not continuous for any value of k. Next one. Next one. In this problem, we need to find the value of k so that the function is continuous. Since the function assumed to be continuous, we have limit of f of x as x tends to 0. What is that function? 1 minus cos of kx upon x sin x equal to f of 0, that is 1 by 2. Now, when you take the value of x in this expression, what happens? 1 minus cos 0 upon 0 into sin 0. 1 minus 1 upon 0. 0 upon 0 form. So we can use L'Hopital rule. Use L'Hopital rule. What does the rule says? Just differentiate numerator and denominator separately and then apply the limit. So this given limit equal to limit x tends to 0. Differentiate the numerator. 0 plus sine of kx into coefficient of xk. In the denominator, apply product rule. Differentiate the first, keep the second as it is, plus keep the first one as it is, differentiate the second. Now, if you take x equal to 0 in this expression, let us see what happens. Sine 0 is 0. Here 0. 0 into cos 0 is 1, but 0 into 1 is 0. So you get 0 by 0 form. So again, apply the same rule. Limit x tends to 0. Differentiate the numerator. Cos of kx into k, and you already have one k. Now denominator, derivative of sin x, cos x, plus product rule. Differentiate the first, keep the second as it is, plus first one as it is, differentiate the second, equal to 1 by 2. Now put x equal to 0. What happens? Cos 0 into k square upon cos 0 plus cos 0 plus 0. 0 into sin, whatever it is, 0 only, 1 by 2. Since cos 0 is 1, so you get 1 upon 1 plus 1. 1 into k square, that is equal to 1 by 2. So k square upon 2 is 1 by 2. K square is 1. So that implies k is plus or minus 1. Next one, 8th one. Here we need to find the value of k so that the function is continuous at the given point. What is the given point? X equal to 0. Since the function is continuous, left hand limit, right hand limit must be equal to f of 0. What is f of 0? Look at this one. X greater than 0 or equal to 0. Read it from right to left. X greater than or equal to 0. In both the cases, the function is defined as 2x plus 1 upon x minus 1. So here you can write left hand limit equal to right hand limit equal to f of 0. So we shall equate left hand limit and f of 0 because it is given to be continuous. In other words, we need to find k so that the function is continuous at x equal to 0. If a function is continuous at x equal to 0, left hand limit, right hand limit and f of 0 all must be same. Now the left hand limit is limit x less than 0, x tends to 0. Take the appropriate function 1 plus kx minus root of 1 minus kx upon x equal to f of 0. 2 times 0 plus 1 upon 0 minus 1. That reduces to minus 1. Now when you take the value of x as 0 in this expression, you get root of 1 minus root of 1 upon 0. Reduces to 0 by 0. So again here use L'Hopital rule. that is differentiate numerator and denominator separately. 1 by 2 root of 1 plus kx into coefficient of x minus 1 over 2 times root of 1 minus kx into coefficient of x, that is minus k upon 1 equal to minus 1. Now you replace x by 0. K upon 2 times 1 plus 0 minus of minus plus k upon 2 times 1 minus 0 equal to minus 1. So this is k upon 2 plus k upon 2, which is k. So k is minus 1. In 9th question, we need to find the value of k so that the function is continuous at the given point. The given point is at x equal to 2. So if the function is continuous at x equal to 2, the limit of f of x at x equal to 2 will be same as f of 2. That is limit of x tends to 2. F of x is 2 power x plus 2 minus 16 upon 4 power x minus 16 equal to f of 2 is k. Now, if we replace x by 2 in this expression, let us see what we get. 2 raised to the power of 2 plus 2 minus 16 upon 4 power 2 upon 6 minus 16. That is 16 minus 16 upon 16 minus 16. 0 upon 0 form. So we can use L'Hopital rule, that is just differentiate numerator and denominator separately before you apply the limit. Derivative of 2 power x plus 2 is 2 power x plus 2 into log 2 into derivative of x plus 2 chain rule, which is 1 only, minus derivative of 16, 0. Derivative of 4 power x is 4 power x into log 4 minus 0 equal to k. Now we shall replace x by 2. 2 power 2 plus 2 log of 2 upon 4 power 2 log of 4 equal to k. So here 2 power 4, that is 16. 4 square 16 get cancelled. Further you can write this log of 4 as log of 2 square, log of 2 square, and the 2, the power 2 comes out. Because remember this, log of a power n is n times log a, this using this formula. That becomes log 2 upon 2 times log 2 equal to k. These two get cancelled. We get k equal to 1 by 2. Given f of x equal to e power 1 by x upon 1 plus e power 1 by x. If x is a non-zero real number, when x is 0, f of x is defined as 0. Now we need to discuss the continuity of the function at x equal to 0. First we shall try to find the limit of the function. For that we shall find separately left hand limit and right hand limit. Left hand limit of the function, limit x tends to 0 minus approaching 0 through the values which are less than 0, that is from the left of 0. F of x is this expression. Now you are approaching 0 from the left. In order to evaluate this, all you need to do is take the limit h tends to 0, and wherever you have x, replace it by 0 minus h. This method is already given in the earlier problems. Limit h tends to 0, e power minus 1 by h upon 1 plus e power minus 1 by h. Now look at this. As h tends to 0, 1 by h tends to infinity. So therefore, e power 1 by h also tends to infinity. As the power becomes larger and larger, e is greater than 1. So the value of e power 1 by h also increases. As it approaches to infinity, the reciprocal of that, that is 1 upon e power 1 by h, which is same as e power minus 1 by h, approaches to 0. So now the limit becomes 0 upon 1 plus 0, that is 0 upon 1, 0. Left hand limit of the function is 0. Now we shall find the right hand limit of the function. RHL. So here approaching 0 from the right, 0 plus you get. Here replace this by h tends to 0, that is 0 plus h, 0 plus h, here plus, here plus. Now again, as h tends to 0, 1 by h tends to infinity, e power 1 by h tends to infinity. Now in this expression, if I take e power 1 by h as a common factor in the denominator, e power 1 by h out, this will be e power minus 1 by h plus 1. Now these two get cancelled. You get this expression. That is limit h tends to 0, 1 upon e power minus 1 by h plus 1. As h tends to 0, 1 by e power 1 by h, rather e power minus 1 by h tends to 0. So this becomes 1 upon 0 plus 1. So right hand limit is 1, but left hand limit was 0. So left hand limit not equal to right hand limit. So limit of the function as x tends to 0 does not exist. So therefore, f is not continuous. Limit itself is not defined at x equal to 0. Eleventh problem. Discuss the continuity of the function at x equal to a. So the function is defined as mod of x minus a into sine of 1 upon x minus a if x not equal to a, and f of x is 0 when x is a. A may be any real number. Now the value of f of a is 0, that is given. F of x is 0 if x equal to a. So f of a is 0. Now we shall find the limit of the function as x tends to a. F of x, that is limit of x tends to a mod of x minus a into sine of 1 upon x minus a. Using properties of limits, separately you can take limit for mod of x minus a, and for sine of 1 upon x minus a. That is limit of sine of 1 upon x minus a as x tends to a. Now you can replace x by a here, a minus a into here as x tends to a, x minus a tends to 0, and therefore reciprocal of that approaches to infinity, becomes larger and larger quantity. However large the value of an angle, the sine of an angle always lies between -1 and +1. If you take the limit sine of 1 upon x minus a as x tends to a, this limit doesn't exist because this doesn't approach us to a definite value. But as this becomes larger and larger, however large or however small the value of the angle, the sine of an angle always lies between -1 and +1. So the value of this oscillates between -1 and +1 as x tends to a. That is, a finite value oscillates between -1 and +1. That will be multiplied by 0. So whatever the finite value here, when it is multiplied by 0, we get it as 0, which is same as f of a. So we got limit of f of x as x tends to a is same as f of a. Therefore, f is continuous at x equal to a. At x equal to a. Twelfth problem. Here, f of x is given to be a continuous function. Now we need to find the value of a. F is a continuous function, means that f is continuous at every point of its domain. In particular, f of x is continuous at x equal to 1. Therefore, limit of f of x as x tends to 1 is f of 1. Since the limit exists, left hand and right hand limits must be same. So you get limit x tends to 1 minus f of x, that is limit x tends to f of x as x tends to 1 plus, that is f of 1. Now the left hand limit, that is x approaching to the value 1 through the values which are lesser than 1. That means x is less than 1. So when x is less than 1, f of x is x plus 2. So we can write here f of x, x plus 2. And now you don't have to write any sign here because we have taken the appropriate function. As x is greater than 1, f of x is defined as ax plus 1. Now, replace x by 1, 1 plus 2, that is a into 1 plus 1 equal to f of 1, replace x by 1 here in this. So that is a times 1 plus 1. So 3 equal to a plus 1. Just equate these two. That is enough. So that implies a is 2. So if you take a equal to 2, this function will be continuous. 13th question. If f of x is continuous at x equal to 2, find the value of a. Since the function is continuous at x equal to 2, limit of f of x as x tends to 2 will be same as f of 2. That means limiting value must be same as the functional value. So that is limit of f of x is x cube plus x square minus 16x plus 20 upon x minus 2 the whole square as x tends to 2. So f of 2 is k. That is k here. Now, when you take the value of x in this function, let us see what we get. 2 cube plus 2 square minus 16 into 2 plus 20 upon 2 minus 2 whole square. That will be 8 plus 4 minus 32 plus 20 upon 0. Numerator also get 0. 0 upon 0 form. So we can use L'Hopital rule here. The rule states that before you apply the limit, differentiate numerator and denominator separately. Limit x tends to 2. Derivative of the numerator 3x square plus 2x minus 16 plus 0. Derivative of denominator 2 times x minus 2 equal to k. Again, now you take the value of x in this function. Let us see what we get. 3 into 2 square plus 2 times 2 minus 16 upon 2 times 2 minus 2. In the numerator, 12 plus 4, 16 minus 16, 0. In the denominator, 0. Again, 0 upon 0 form. So apply the L'Hopital rule. Again, limit x tends to 2. Differentiate numerator, denominator separately. That is 6x plus 2. Derivative of denominator. Derivative of x is 1. Derivative of 2 is 0 equal to k. Now you take the value of x is 2. 6 into 2 plus 2 upon 2 equal to k. So you get 12 plus 2 upon 2 equal to k. So k is 14 upon 2, that is 7. So when we take the value of k as 7, the function becomes continuous at x equal to 2. Fourteenth question. This is taken from KCET paper 2014. It's given that the function is continuous at x equal to 0. Then we need to find the value of k. Since the function is continuous at x equal to 0, limit x tends to 0 of the function f of x equal to f of 0. So f of 0 is 2k here. Now limit of the function 3 times sine of pi x upon 5x as x tends to 0 is 2k. So what is the value of this limit? Directly you can write this as 3 pi upon 5 equal to 2k. Therefore, k is 3 pi upon 10. Remember this, limit x tends to 0, sine of ax upon bx. You just keep the coefficients outside, a by b. That is the value of sine of ax upon bx as x tends to 0. So here in the same way, just take pi outside, 5 outside. 3 times pi by 5. So k is 3 pi by 10. This is plus 3 pi by 10. Now question number 15. It's given that the function is continuous. Find k. Once the function is continuous, it is continuous at every point. So in particular, the function is continuous at x equal to 5. So therefore, you can write this as limit of f of x as x tends to 5 equal to f of 5. Now, since the function is defined separately for less than or equal to 5 and greater than 5, here we need to take left hand limit and right hand limit. Since f of x is continuous, the limit is defined. Left hand limit and right hand limit are equal and both are equal to f of 5. So left hand limit x tends to 5 minus, that is approaching 5 from the left, that is through the values which are lesser than 5, equal to right hand limit of f of x as x tends to 5 plus. Now here limit x tends to 5. Once you take the appropriate expression for f of x, no need to write any sign here. When x is less than 5, the function is 3x minus 8. So take that as 3x minus 8. So that is equal to right hand limit as x tends to 5 plus. When x is greater than 5, the function is defined as 2k. So you can write limit x tends to 5 to k. That's enough. These two enough to equate. Now 3 into 5 minus 8 equal to 2k. There is no x to substitute. 15 minus 8, 7 equal to 2k. Therefore, k is 7 upon 2. So the first option is the answer. 16th question. The function f of x is defined as bracket x. Bracket x is the greatest integer function. We need to find at what point the function is continuous. At 1.5 or at 1 or minus 2 or at 4. This question appeared in KCET exam 2015. Now we shall consider the graph of the function bracket x, greatest integer function. Look at this. Bracket of 0 is 0, 0.0, 0.1, 0.9. Up to 1 it is 0 only. At 1 there is a shift. Bracket of 1 is 1 only. Bracket of 1.1, 1.2, 1.3, 1.999 all equal to 1 only. Anyway, you know that one. In the graph, you can see that at integral points 1, 2, 3, minus 1, minus 2, minus 3 and so on, you have a break in the curve. So when you have a break in the curve, the function is not continuous. So clearly the function is not continuous at integral points 1, 2, 3, 0, minus 1, minus 2 and so on. So but it is continuous at non-integral points. Suppose I take 0.25, this point. It is continuous, no break. 1.5, no break here, curve, no break. 2.7, the curve has no break. So the function is continuous at x equal to 1.5. That is the correct answer. Now, in this question, the function is given to be continuous at x equal to 2. Now we need to find the value of k. So since the function is continuous at x equal to 2, limit of the function as x tends to 2 will be same as f of 2. So when the limit of the function is defined, then left hand limit and right hand limit both are defined and they are equal. In particular, they are equal to f of 2. You can write this as left hand limit. So x tends to 2 minus f of x. Right hand limit x tends to 2 plus f of x and f of 2. So here left hand limit x tends to 2. When x is less than 2, the function is defined as k times x square. So once you take the appropriate function, no need to write any sign here. So that is equal to limit x tends to 2 when x is greater than 2. The function is defined as 3. And f of 2. So here when x is equal to 2, the function is defined as k times x square. Replace x by 2, k times 2 square. So these two is enough for us to equate. This is 3, this is 4k. Therefore, k is 3 upon 4. Question number 18. If f of x is continuous at x equal to 1, then the value of k is, the options are e, 1, minus 1, 0. Since the function is given to be continuous at x equal to 1, limit of the function as x tends to 1 is same as f of 1. So f of 1 is given to be k, and when x is not equal to 1, the function is defined as log x upon x minus 1. Limit x tends to 1, log x upon x minus 1 equal to k. Now, when you take the value of x as 1 in this expression, that is log of 1 upon 1 minus 1, log 1 is 0 upon 0, 0 upon 0 form. So we can apply L'Hopital's rule. For that, all you need to do is differentiate numerator and denominator separately. 1 by x, 1 minus 0. Now take x equal to 1. That implies 1 upon 1 by 1 equal to k. So we get the value of k is 1. So the correct option is second one. Question number 19. It's taken from KCET exam 2019. It's given that the function is continuous at x equal to 0, then the value of k, which we need to find. The given options are 3 by 2, 9 by 5, 7 by 2, 2 by 3. Since f of x is continuous at x equal to 0, limit of f of x as x tends to 0 is same as f of 0. So here when x is 0, f of x is defined as k minus 2. Limit f of x is sine of 3x upon e power 2x minus 1. Limit x tends to 0. This is k minus 2. Now if you put x equal to 0 in this function, let us see what we get. Sine of 3 times 0, 0, e power 0 minus 1. Sine 0 is 0. E power 0 is 1 minus 1. That is again 0 by 0 form. So we can use L'Hopital's rule. For that, you need to differentiate numerator and denominator separately. This is 3 times cos 3x, that is derivative of sin 3x. Derivative of e power 2x is e power 2x into 2. Derivative of 1 is 0. So k minus 2 as it is. Now replace x by 0. 3 times cos 0 upon e power 0 into 2 minus 0 equal to k minus 2. Cos 0 is 1. So you get 3 into 1 upon 2 equal to k minus 2. So that gives us k equal to 3 by 2 plus 2, which is 7 by 2. So the answer is the third option. Now question number 20. If the function is continuous at x equal to 0, then the value of k is plus or minus 1, plus or minus 1 by 2, 0 or plus or minus 2. Since the function is given to be continuous at x equal to 0, by definition of continuity, at a given point, we have limit of f of x as x tends to 0 is same as the value of f of x at 0, that is f of 0. So f of 0 is given to be 1 by 2. Now that implies limit x tends to 0, 1 minus cos of k times x upon x sin x equal to half. Now, but when you take the value of x equal to 1 in this function, let us see what you get. 1 minus cos of 0 upon 0 into sin 0. Cos 0 is 1 upon 0, that is 0 upon 0 form. So we can use L'Hopital's rule. So before you take the limit, just differentiate numerator and denominator separately. 0 derivative of cos x minus sin x, that becomes plus sin of kx into coefficient of x, that is k, chain rule. Here the product rule, differentiate the first, keep the second as it is, plus keep the first as it is, differentiate the second, derivative of sin x, cos x. Now, if you take x equal to 0 in this, what you get? Sin of 0 into k upon sin 0 plus 0 into cos 0. That becomes 0 into k, 0 plus 0 into 1. So numerator becomes 0, denominator also 0. So again we get 0 by 0 form. So again we can apply the L'Hopital rule, that is the given limit is again same as the limit of the function which is obtained by differentiating numerator and denominator separately, that is limit x tends to 0. If we differentiate the numerator, derivative of sin x, cos x, but coefficient of x is k, k into k you already have, so you get k square in the numerator. In the denominator, derivative of sin x is cos x. Now again x into cos x, product rule, differentiate first function, keep the second as it is, plus keep the first one as it is, differentiate the second, that is equal to 1 by 2. Now take the value of x equal to 0. Cos 0 into k square cos of 0 plus cos of 0 plus 0 into minus sin 0. 1 by 2. 1 into k square cos 0 is 1 plus 1 plus 0 equal to 1 by 2. So that gives us k square upon 2 equal to 1 upon 2. So you get k square equal to 1. 2 get cancelled. Therefore, k is plus or minus root 1, that is 1. So the correct option is the first one. Now question number 21 is taken from KCET 2022. If f of x is defined as x square minus 1 when x lies between 0 and 2, and 2x plus 3 if x is such that 2 less than or equal to x less than 3. The quadratic equation whose roots are limit of f of x as x tends to 2 minus, that is left hand limit of the function as x tends to 2, and limit of f of x as x tends to 2 plus, which is the right hand limit of the function as x tends to 2. So if you take these values as alpha and beta, now we need to find the quadratic equation whose roots are alpha and beta. Let us take alpha as LHL limit x tends to 2 minus f of x. Limit of f of x when x is less than 2. The function is defined as x square minus 1. So you can write x square minus 1 limit x tends to 2. Now you replace x by 2. 2 square minus 1, 4 minus 1, 3. So alpha is 3. Beta is the limit of the function as x tends to 2 plus, that is right hand limit. The function is defined as 2x plus 3 when x is less than 3 and greater than 2. So we need here greater than 2. So limit x tends to 2, 2x plus 3. Replace x by 2. That is 4 plus 3, 7. So beta is 7. Now we have two values, alpha and beta. We need to find the quadratic equation whose roots are alpha and beta. When you have two roots of a quadratic equation, you can easily write the quadratic equation. So x square minus sum of the roots into x plus product of the roots alpha into beta equal to 0. This will be the required quadratic equation. Just substitute for alpha and beta. So we get x square minus 3 plus 7, 10 times x, 3 into 7, 21 equal to 0. So this is the required quadratic equation. So correct option is option 3. Now question number 22. So here we need to find the value of this limit. Now if you directly replace y by 0, this takes the form root of 3 plus 0 minus root 3 upon 0 cube 0. 0 upon 0 form. So you can apply L'Hopital's rule. So that is limit L equal to limit y tends to 0. Differentiate the numerator. 1 by 2 root of 3 plus y cube into derivative of root x is 1 by 2 root x. But in place of x, you have this. Rather, we are differentiating with respect to y. Derivative of root y is 1 by 2 root y. In place of y, you have 3 plus y cube. By chain rule, this has to be differentiated. So that will be 3y square minus derivative constant is 0. Derivative of y cube is 3y square. Now these two get cancelled. Now limit of 1 upon 2 times root of 3 plus y cube as y tends to 0. Just replace y by 0. You get a definite value, that is 1 upon 2 root 3. So that is the value of the given limit. So the correct option is the first option.